Alright, welcome to the 1.9 homework video, and in this we're going to go ahead and again do the different format here where I'll do it by hand so I can show you all of the patty paper and that I'm going to be using to do these problems. Starting with numbers 1 through 3, it says to say whether the transformations are rigid or non-rigid. So rigid just means that if you rotate it or you translate it or you reflect it, it maintains the same size and shape. And so 1 would be yes, it is a rigid transformation, and then 2 and 3 would be non-rigid because in 2 it has a different shape, and then in 3 it has a different size. So, okay, and then from there we'll go ahead and go ahead and there we go. So 1 is rigid, 2 is non-rigid, and 3 is non-rigid. Okay. Next would be number 8. That's at the bottom of this page right here. So number 8. Translate the vector by the translation vector, and it in the direction it says copy the figure onto graph or square dot paper and perform each transformation. So I am actually going to go ahead and copy it onto patty paper here. There we go. So now I have it on patty paper, and what I can do is copy the image right there. Now I'm going to flip it over so that the lead is facing down onto the paper, and then I'll move it the distance of the translation vector and put pressure on it like that, and then you'll see what'll happen is there'll be a very light, you can't really see it in the video, but there's a very light outline of the shape, and I just trace over it with pencil, and I have the image of it. The other way to do it would be just to count. This is over 1, 2, 3. So 1, 2, this would be here, 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 and then this point will be right here. You can kind of estimate the shape would be right there. Okay, next I'm going to go ahead and work through 9, 10, and 11. So for this one, transform each triangle on the coordinate plane by the given rule. So let's start with the first one. And rather than drawing on the paper, I'm actually just going to move it with patty paper here. Okay, so this one is going to go 3 to the left. So 1, 2, 3, and then 2 up. And so the image would be right here, and we would do P prime, Q prime, R prime to indicate that it's an image. That looks just like that. Okay. The next one, we're going to do 1 to the left and 4 down. So 1 to the left, 1, 2, 3, 4 down, and that would be the image. The next one is a reflection across the x-axis. Now there's 2 ways to do it. One would be go ahead and trace it out, or actually I already have it traced out. Let me just do this here. And then you fold it right along the x-axis, which is right where PQ is. And you get that, and then that would be the image right there. The other way to do it, though, is to count. So we know that R is 1, 2, 3 away. So the image will be 1, 2, 3 away. Right below it, that will be R prime. And these are on the x-axis, so they'll just stay there. And that would be your image right there. Okay. Next is 16 through 22. Okay, so in this one, it does say to use patty paper this time, so copy the original figure onto patty paper and fold to locate the line of reflection so that the reflected image coincide with the original, and explain your reasoning. Okay, so I'm going to go ahead and copy this down here like that. And what I need to do is fold it so that one line folds onto another line. We're basically making an angle bisector here. So if I go ahead and take this and fold it over so that this image lies on the other one. Let's see. Yep, right there. Okay. So if I fold it over, that ray lies on the other ray, and this gives me the line of reflection. Like you see there. Look at that. There's a line of reflection. That is number 16. Now with 17, it's going to be similar. Go ahead and trace the pentagon, 5-side polygon. It's a pentagon. And then, let's see here. How can I fold this so that it's image? Can't fold it that way. Oh, here we go. I think the rough place to fold it would be about right here, and then I can see that this, when it folds onto that, will fold onto itself. So let's go ahead and do that. There we go. That's going to give me line of reflection right there. Okay. So that's 17. The next one would be 18. And this one, it says to perform each transformation, attach your patty paper to your homework. I do have lots of patty paper available in the classroom. If you need some, you can grab some. Also, any local bakery, they're often used for pastries. You should be able to grab a few of them there if you need some. So copy the figure and a line of reflection onto a piece of pad paper and fold the paper and trace the figure to construct the reflected image. So I'll go ahead and do that here. I think it can be helpful to use a straight edge when doing this. There's a line of reflection. And then I'll need to copy this. And then this one. There we go. Okay, the rest I'm just going to trace. Okay, there's my figure, and I'll go ahead and copy it and fold it along the line of reflection. You see I fold it there. Now what I'm going to do is just put some pressure on it, and what will happen is, because the lead's on this side, it will bleed onto the paper. And if I just apply enough pressure, I'll get an approximate outline of my image. Okay, and there I go. Now I'm just going to trace over this. Okay, and there's my original and its image. It's number 18. And the next I'll do 19 on the same sheet here. Copy the figure and its reflected image onto a piece of pad paper and locate the line of reflection. Explain your method. So I'll go ahead and copy. Original and its image. Okay. And then all I need to do to locate the line of reflection is fold it over until one figure lies on top of the other one. There we go. Okay. There it is. Line of reflection. It says to explain your method. I folded the patty paper so that the original figure lined up with its image. The fold line is the line of reflection. There we go. So I folded the patty paper, or the patty, so that the original figure lined up with its image. The fold line is a line of reflection. Again, I folded the patty, I should say patty paper, I think. Okay, that is 19. Next would be 20, and then 21 and 22. So with 20, go ahead and trace the circular figure and the center of rotation P. Rotate the design 90 degrees clockwise about point P and draw the image of the figure as well as the dotted line. Okay, so let's see here. Trace circular figure and the center of rotation P. So I'll kind of try to have P at about the center of my patty paper. And then go ahead and trace this dashed line, and then I'll trace over the circle here. Okay, so there's a pretty good trace. Now what do is rotate the design 90 degrees clockwise and draw the image of the figure as well as the dashed line. Okay, so for this one I'm going to need 2 sheets of patty paper. What I'm going to do then is with this one I'll go ahead and trace the figure again. Okay. And what I'm going to do then is rotate this 90 degrees and then trace that on there. The problem is though, if I were to do it right now, the pencil side's on top and I need the pencil side to be on the bottom. But if I just trace that, the orientation changes. So I'm going to go ahead and trace over what I copied. This is the second sheet of patty paper and I'm just tracing over it. Alright, so I'll line my pencil up right here. Looks like I got it. Move this out of the way real quick. So I got it lined up pretty good. Rotate it about 90 degrees. See how the angle between those dashed lines is a right angle? That means it's 90 degrees. And then all I need to do is, oh, this one already had some markings on it. Oops. Well, it's on the other side. It is. Okay. There we go. So 90 degrees clockwise. Oh, wait. Which way does the clock go? It goes this way, not that way. Try again. Okay. 90 degrees clockwise is up here. And see, it's a 90-degree angle between those dashed lines, and now all I need to do is trace over, let the pencil bleed through, like that. And look at that. Got a nice outline of the shape. And so then I'm just gonna go over it again. Okay, now I can see this is a 90-degree clockwise rotation, and this is number 20. I think I'm supposed to draw the image and the dotted line. Okay. Dotted line just goes to the center there, so I'm gonna, there we go. Okay, I'm done. That should be a right angle because it's a 90-degree rotation. And that's 20. Okay, excellent. Okay, final 2 problems. 21. Triangle RSE with circle O. A random point on RS are reflected across line P to create triangle R prime, S prime, E prime. Which of the following statements are true, and explain how you know? All right. So let's see. Is RE Is RE congruent to R prime E prime? Yes, it's a rigid transformation, so this will stay the same. So with 21, A is true. And next is B. Angle S congruent to angle S prime. Yes, they are. They look congruent, and it's a rigid transformation, so it has the same size and shape. So B is also true. And why is it true? Because it's a rigid transformation. Rigid transformation has the same size. And that would be true. Another name for rigid transformation is isometry. So it's an isometry. It has the same size and shape. And next is C, R prime, O prime, and S prime are collinear. R prime, O prime, and S prime are collinear. That would be true. So that's because of its isometry. Has same shape. And so those points, when they're folded, are going to lie right on top of each other, and they'll still be on the same line. And a reflection maps the original figure onto an image. So points will still be collinear. Okay. Cool. So that's C, and then D says what? The distance from S to line P is equal distance from S prime to line P. That is true. That is true because in a reflection, the original point and its image are, here's a new word, equidistant. Same distance from the line of reflection. And that's really by the definition of what a reflection is. That is true. So the reflection is what's called a perpendicular bisector of this segment, which we'll talk more about later. But there you go. That is true. So next is 22. 22. So 22A. Triangle ABC with M being the midpoint of AC are translated to create A prime, B prime, C prime. Which of the following statements are true? So A is true because it's a rigid transformation. Because it is a rigid transformation. B it says that angle C is congruent to angle C prime. That is true. Same reason as A. And C, M prime is the midpoint of A prime. That is true. Since each point is moved the same distance and direction, M prime will remain the midpoint of A prime, C prime. And so it'll be the same orientation since each has moved the same distance. And finally is B prime congruent to M prime, and again this is true for a similar reason as to C, is that in a translation each point is moved the same distance in the same direction as a translation vector. And because each point in a translation is moved the same distance, called a translation vector. Now, a vector has two things. It has distance and direction, and so that distance of the vector is the distance that each point's moved. Okay, well that concludes the 1.9 homework. Thank you for listening. Hope that was helpful.